Okay. What does congruent mean?
Same.
Same?
Equal. Parallel. I don't know.
Same blank, same blank. Same size, same shape. You need to write that in your notes. The definition of congruence. Same size. The entire purpose of today is to determine congruence. The answer is yes or no. So let's try it.
No. Oh, you get to go eat some treats.
Here we go. Congruent. Yes or no?
No.
Justify your answer.
One to
On the
the
circle.
triangle.
Okay, I'm glad that you can see that.
One's pointy, one's round.
Nope.
One has three sides.
Nope.
One has this side.
Different shapes.
Different shapes.
There you go, pal.
They are almost the same size, air quotes, but they are completely different shapes. It fails the congruence. Right? So you're right. You're right. One's a triangle, one's a circle. But specifically, they're different shapes. They do not meet this criteria, same shape. Let's try it again.
Ooh, same
Same size,
shape for different size.
Yeah. Caught you.
What do you think? Same size, same shape, congruent, yes or no?
No.
Why not?
Different sizes.
Wow.
Different sizes, okay?
Alright, now it's congruent.
Okay.
Congruent, yes or no?
Yes.
No!
Oh, okay.
Wait.
I told y'all.
You know,
Logan.
Go ahead, say it, Carson.
they're congruent.
Are you sure?
Yes, you got the same thing, duplicated it, and put it on the board.
But does it say that?
No.
There's no marks. So you assume that they're the same. So look, the definition of congruence is 3 same sides, 3 same angles. They all have to match. So if it's not listed, it's not true. Now, are you ready?
Alrighty. So you're saying if it don't say it's congruent, it's not congruent?
If it does not say it's congruent, it's not true.
No, it's not.
Congruent, yes or no?
No.
Yes.
Yes.
I hate this.
Yeah.
I hate this.
Don't freak out.
How bad can y'all be?
Does it have one set of congruent sides?
Yes.
One tick, correct.
Mm-hmm.
2 ticks, 2 ticks. Yes. 5 and 5. Yes.
Yeah.
Okay? So we have 3 sets of congruent sides. Does it say anything about the angles? No. All I know right now is that they're similar. I don't know anything about the angles. So I have to go back and make sure you know. I'm going to make sure I do it right. Congruent, yes or no?
Yes.
Yes. Finally, very, very specific.
Yes.
3 sets of congruent sides, 3 sets of congruent angles. Okay? Does that make sense? I make that really complicated for no reason?
No.
Okay, so as we move forward, you'll see 2 different kinds of things. You'll see one, a statement. It says, given A, B, C, D is congruent to Q, R, S, T, find all the corresponding parts using the names. We call this the circle technique. So because I have A, B, C, D is congruent to Q, R, S, T, I use the circle technique to identify congruent angles. Angle A and angle Q are congruent. Matching. Write that down. Let's continue the pattern. If A and Q are congruent, then
E and R.
B and R.
angle B is congruent to angle R. Guys, this is the first, or this is 4 questions on your homework right here.
It's light.
Light work all day. Baby, wait.
Wait, but how many questions is on homework?
10.
Oh, okay.
Like I'm saying, I'm giving you something you can do tonight. What's the next one?
C
C as in
Angle
DT.
angle C is congruent to angle. I can't see. Oh, S.
It's on your paper too. Angle C is congruent to angle S. And then the last one.
D.
Angle D is congruent to angle T. Okay, it's a four-sided shape. It has four angles. I just listed it using AKA the circle technique. Okay, by circle techniques, alright. I'm not a huge fan of it, but it works pretty good. So the next thing says use the circle technique to identify congruent sides. So what's the first one that's circled?
BC RS.
Line segment BC is congruent to line segment RS because they are pieces of lines. Thank you.
Yeah.
Keep going.
Angle.
That means
A,
angles.
okay, line AB.
AB
Yeah.
and
QR.
the first two letters or the first two line segments. Line segment AB is congruent to line segment QR. Line segment CD is congruent to line segment.
SC.
Oh.
Okay, well we have three sides of a four-sided figure.
In AD and QT.
That's the last one. So it wraps back around.
Oh, I thought it had to be two.
That is good.
Because here's what's happened. So I'll ask you guys to do this too. Like if you draw a quadrilateral and I say A, B, C, D clockwise, I must start at the same spot and go clockwise again. Q, R, S, T. This is easier for me to see personally. A, B, Q, R. That's this statement right here. B, C, R, S. That's the first statement.
Do it.
Huh?
That's a smart way to do it.
Alright, so different strokes for different folks. And then it gets you that last one that you may not have seen. 1, 2, 3, 4. 1, 2, 3, 4. I like doing it that way. One problem with that is you have to know how to draw it and how to label it correctly. That's not super complicated, but there is an area for you to make a mistake there. Or reading it, you might get 3 out of the 4. So now we're going to skip all the way to this thing where it says you have two shapes. I love these little puzzles. It says what shape is congruent to what shape. So I'm offering you something different. Here's two pictures, but they're not lined up right now. I need you to do something and manipulate that red shape so it's in the same orientation as the black shape. Rotate, flip it. So go ahead and write me a statement. Like right now, I'm going to start with A and go B, C, D like this. A, B, C, D. And I'm going to try and figure out what it's congruent to. And you would write a statement down here. Everything has to match up. So you think it's H, G, F, K, or how do you think it works?
I think G's going.
Hold on, that.
Wait, hold up. No, never mind. FGHK.
Then we have one guess, F, G, H, K.
Wait.
It's confusing, right?
FK, GH.
Maybe I have to flip it. Flip it. Now rotate.
Rotate.
Bigger, you see. You have to flip it.
Can I make that work?
No.
No.
Transform.
Ooh.
Okay.
He's going like in the back.
He
tricks.
knows.
He's been on the online.
You've been working this off.
Oh, come on, shape.
Work with me.
Oh.
So here's what I did pre-technology.
You just turned your paper.
FK.
I traced it right here. That went like this. That doesn't. This is easier to manipulate because it's not technology. And then, like you said, so it is A B C D F G H K. A B C D F G H K. That one's tough, right? So as you're able to redraw it and make it work, it goes F G H K. That's how it should map out. So you need to write the congruent statement. A B C D is congruent to F G H K, and you can kind of start making your list from there. All right. Here's another fun one. This one's a little more tough because it's got 5 sides. That's called a pentagon. So I can take it here.
That's easy. It's just mirrored.
And I can start turning it.
Yeah. Nah, they're not.
That didn't work, did it? Where is it?
Oh wait, never mind.
So now you have A, B, C, D, E is congruent to P, Q, R, S, T as you turn it. All right, this is tough, right, for you guys?
No.
But look, we're in geometry and we're starting baby steps. So what about this one?
What's the light?
So if they were congruent, how would you write the congruent statement? ABC? Does it have to be ABC?
No.
Okay, but we picked ABC.
A, B, C, X, D, X.
So start at the top,
X.
go down the diagonal, come across. That would be your congruent statement. That's a lot easier to see, right? So that's where we're going to live in this world right now, pretty much just triangles. To get you guys confident. Have we done any math yet?
No. Just matching.
Okay, let's do some math.
Hey,
But it's not math. It is matching. We have 2 triangles. We have A, B, C, D, E, F. This is supposed to be angle A right here. So if A is 30, then D is 30. Well done, Robert. Because A and D match each other. If E is 65, look at you guys go.
I know.
And then some point in the past, you should have learned
85 degrees.
that how many degrees are in a triangle?
180.
180. I have 2 of them, 30 and 65 and something equals 180. Add these together and you get 95. So I want to subtract 95 from both sides.
And you get 85.
So if the third angle of this triangle is 85, how big is the third angle of this triangle? Guess what you guys just did, Robert?
We just did some math.
You just missed a whole geometry concept. The third angle of this triangle is 85.
F is 85.
The third angle of the other triangle is 85. That's called the third angle theorem. So if you prove two angles in this triangle, and two angles in that triangle are the same, you can just say, hey, the third angles are the same. That's called the third angle theorem. Pretty cool, right? The third angle theorem. Do we need to talk about that? We have two angles in ABC that are congruent to two angles in FED. What can you say about the missing two angles? They are congruent, hence the third angle theorem.
That's it.
So, look at triangle GHJ and triangle IGH. Can you say that these two triangles are congruent?
Yes.
Do they have three congruent sides?
Yes.
1, 2. Where's the third one?
The side, like the inside.
This guy right here?
Yeah.
How do you know that's the same?
Because of the little
Threes are nine.
Because
Threes are nine. You're supposed to add up to 180.
No, I'm asking about the side length of it. How do I know that this side of the top triangle is the same as this side of the bottom triangle?
Because the third side are congruent.
It's because it's right next to each other. You don't see nothing behind them.
It's a reflection. There's only one line.
Because it's only one line. So it's the same as itself, right?
Now we're done.
It's weird, right? This line is the line for the bottom triangle, and this line is the line for the top triangle. It's the same line. Does it make sense that it would be different? That's why it's unmarked. So, check. Three sides that are the same. Do I have angles that are the same?
Yes.
Do I have angles that are the same?
Yes.
But do I have any angles over here that are the same?
Then you just
I do. How do I justify that this angle and this angle are the same?
Because the third angle.
The third angle theorem.
the
Yay! So now I have three sides that are the same. I have three angles that are the same. Are those triangles congruent? Yay! What about over here?
yeah.
Okay, this is 95. This is 95.
Okay.
Now what?
Q to T.
What about this angle right here?
It's vertical.
Oh, it's a vertical angle for that angle. Are those the same?
Yeah.
So what can you say about R and V?
That they're
They're the same.
They are the same.
Third angle theorem.
The third angle theorem. Okay, so I have three congruent angles. Do I know anything about the sides? No, I don't, do I? So can I say those two triangles are congruent? No, I cannot. I cannot. I have three angles that are the same. What do you think about the sides? No. So I just say I know there are three congruent angles. I know nothing about the sides.
Not enough people get.
Here we go, right? Let's wrap it all together. So, this is what's called exploring the learning. I want you to add the information at the top to the picture at the bottom. Please make angle A and angle C right angles. How do you do that?
The little squares.
You tell them they're not wrong, they are right angles. You're not a left angle, you're a right angle. Bang! The little box means it's a right angle. Any confusion there? Nope. Okay. Number 10. AB is congruent to CD.
Well, let's see.
How do I do that?
You put the
You write
line
the hash
there on
mark.
both.
Mark. Mark. Make sure you're marking the right thing. Nailed it. And AD is congruent to CB.
You put
Two marks.
2 marks.
I need to-
Mark. So pretty tough stuff here. Okay, this one can be confusing if you don't read it slowly. A, D, B, that's this angle right here, is congruent to C, B, D. That's this angle right here. They are marked as congruent. Can you conclude that A, B, D, this angle right here, is congruent to C, D, B, this angle right here? Can you conclude that the right angles are congruent?
Yes.
Yes. How?
Third angle theorem.
Yeah, well done.
Ooh, I like this.
The third angle theorem says that they are the same because you have two congruent angles in one triangle, you have two congruent angles in the other triangle. Ipso facto, the third angles are the same. Can you conclude the third side of both triangles is congruent?
Yes.
Because it's the same line.
Ooh.
Yes. Because it's the same line is not an accepted property in mathematics.
Ooh.
Why not?
Because it's
Because there is a specific word.
vertical line?
Okay, let's play the game. First period.
Transversal.
Okay, R, okay.
It's like we're playing Hangman.
Oh.
Nailed it. First period, one letter.
Reflexive.
Remember that reflection property? Pretty much saying that BD is congruent to BD. That's the reflexive property. It sees a reflection of yourself. Like all you boys flex in the mirror, or people used to. Right? The reflexive property. The reflection property. That is the accepted proof in mathematics. The reflexive property. Cool, right? I have one more thing to show you, and then I'm done. Alright?
We do our homework.
And then I'm going to give you, you should have plenty of time. I think 20 minutes is too long, so I'm going to soak up 2 more minutes. You ready? So, there's going to be a time and point where you guys have to start doing proofs in this class.
Oh no.
Again,
It's not fun.
I'm better at this.
Yes.
Facts. Right? So, we have 2 triangles over there. We are going to geometrically prove the third angle theorem. Are you ready?
Oh yeah.
So, how many marks do you see here?
One.
I'm going to call this angle 1. How many marks do you see here?
One.
I'm going to call that angle 1. How many marks do you see here?
2.
I'm going to call that angle 2. How many marks do you see here?
2.
Okay? I'm going to geometrically prove that no matter what happens, C and F are congruent. What is that called already?
Third angle.
The third angle theorem. That's what I'm trying to prove. I'm trying to prove that C and F are congruent. So, if I want to find the measures of the angles in this triangle right here, angle 1 plus angle 2 plus angle C equals how many degrees total?
180.
180. Okay? The same thing goes for the right triangle, the other triangle. 180 is equal to angle F. So we have this thing called the transitive property. If it's repeated, then it's deleted. So I delete the 180s and I get a new statement. 1 plus 2 plus C is equal to 1 plus 2 plus F.
Now delete the 1 plus.
Right?
So get rid of it.
That's not repeated. It's called the subtraction property because I'm subtracting a 1 from both sides. Subtract the 1 from both sides. Balanced. Subtract the 2 from both sides. Balanced. It mathematically says C equals F.
Oh snap.
Every time, all the time. That is a baby proof for you guys.
Facts.
All day, every day.